All right, recording has started. So welcome everybody to our bi-weekly sprint review meeting. Basically, you all know the drill. In this meeting, we're going to go through all the issues that we've worked on during the last 2 weeks. And that said, I will already hand over to the first one in the list, which is Moritz.
Thank you. I'm going to share quickly. If I find the right window, this one. So the first feature I implemented was auto updates of the Keptn spec submodule in the Keptn repo. So that's the according issue. As you can see here, this is the Keptn specification submodule, and I automated the process of upgrading that specification submodule when a new release in the Keptn spec repo happens. Yeah, and to quickly show you, we have this small Github action now. It's actually in the Keptn repo, not in the spec repo. Yeah, and all it does is check out the new version and then create a PR for it. And the whole thing is triggered by this repository dispatch event that comes from the Keptn spec repo with this specific type. Yeah, and on the other side, in the Keptn spec repo, this event is only sent on push of a release tag. So this is how this is updated now. And then the second feature is actually also regarding the Keptn spec, but this time in the Go utils and the Kubernetes utils repository. Actually, I did the Go utils repository. Let's go to that issue. Basically, in all the cloud events, we have this sh Keptn spec version, and that is set, right, it was set with a constant that had to be updated manually. And basically, that's what I automated now. So now when we go to the PR, we actually, again, have a very similar Github action with the same spec update event that is listened to. Just that the actual behavior is different. So here we write the new Keptn spec version to a config.yaml file, which is then used in the cloud events. So there's a small config for that, which directly through Go embed embeds that config YAML file, and then this is used as the default sh Keptn spec version instead of that constant, that hard-coded constant. That was the 2 big features I implemented, and then in addition to that, I also did some improvements and refactoring here and there for the GitHub Actions pipelines, stuff like Go module updates that happen automatically with the update dependencies and stuff like that. That's it from me, I think. Handing over to Flo.
All right, thank you. Really cool stuff. Let me just share my screen again. All right, in the last 2 weeks, I mainly worked on 2 issues, which were both a little bit on the larger side. So the first one is about termination of orphaned tasks. Basically, what is that about? So in case you have started a task sequence, and nobody actually picked up the task or any task that was sent out to be performed by a certain Keptn execution plane service. We never actually had the concept of a timed out task within our backend. So we never actually knew that the task was timed out. And this has been addressed in this issue. So basically what we now do in the Shipyard controller is we have a certain task started wait duration. This is basically the duration the Shipyard controller will wait until for a certain task it will receive a correlating that started event. And if within that time frame no started event is received.
Flo, I think your sharing is already frozen. Again, like the last time.
Seems like it, yeah.
Are you sharing some source code or?
No, I'm still sharing the issue.
Ah, okay.
All right.
Sorry.
All right. But you see the.
We see the issue, but can you move the mouse?
I think it's still stuck.
I think it's frozen.
Okay. Yeah. Let me just. It is getting really annoying with the screen sharing. Let's try it again. Do you see it now again?
Not
Seems
yet.
like it's blank now. It's exactly like the last time. No, it's blank.
Yeah, well, in that case, I will just explain it on the audio track.
We can imagine.
We can specify a specific wait duration that the Shipyard controller now will wait until sending a triggered event for a task. And if no correlating started event is received after that time frame, the Shipyard controller will then mark the sequence as timed out. And this will also be reflected in the response of the task sequence state endpoint. And yeah, that was the first issue. And the second one, or maybe can somebody else share the GitHub document so we have a little bit of a visual overview?
I can do it.
Yeah, thank you. All right, thank you. The second task I worked on is the migration of old sequences for the new sequence state endpoint. So if you click on this link here, we will get to the issue. So basically, we recently introduced the task sequence state endpoint in the Shipyard controller, which basically returns a list of sequence states for the executed task sequence for a certain project. And this endpoint will be used by the bridge in order to generate the overview of currently ongoing and already executed sequences. And one requirement that we had here in order to really make use of that endpoint in the bridge as well and not lose any information was to migrate the sequences that have been executed before introducing this new endpoint in order for them to be available in the responses for this endpoint as well. And basically what the Shipyard controller does to enable that is during startup, it will fetch a list of all the projects that are currently there in Keptn. And then for each project, it will look up the root events that basically indicate the beginning of a sequence. And for each of those, it will check whether a correlating task sequence state has already been created in the backend. And if not, then it will load the event trace for this task sequence execution. And by applying the event sourcing pattern, it will go through all those events and basically derive the current state of the task sequence that was executed there. And this is done once after the Shipyard controller has been started up, and after that, all the previous task sequence should then have a correlating task sequence state that is also available in this new endpoint. And yeah, this pull request was quite big, but yeah, maybe what's interesting here as well, we do also have an integration test in place here that basically is an extension of the previous task sequence state endpoint. So what it does is executes a task sequence, it verifies that it has the correct state, and afterwards it will copy the event trace under a new context and store the trace in the MongoDB, restarts the Shipyard controller, and since the events for the sequence were added directly within the database without being coordinated by the Shipyard controller, the task sequence state is not available there yet. But after restarting the Shipyard controller, those events will be picked up and the correlating state will be created and persisted in our MongoDB collection. And that's pretty much what this integration test will verify. All right, are there any questions about that?
Not about that, but the previous story you've presented about handling offhand task executions. So am I right that this actually presents then already the groundwork for the upcoming stories, like manually canceling a sequence?
Exactly, yeah.
That's cool.
So that's basically the same concept will be applied. And yeah, that's pretty much the requirement.
So it will be more or less the same logic can be applied to this feature. It's just manually triggered by the user. That's
exactly,
different.
yeah.
That's good.
I have another question. The timeout, can you actually configure it, or is it hard-coded?
You can configure it via the Helm chart. So
yeah, okay.
in the values.yaml file, you can specify this timeout as a duration string, like 10m, for example. And this will be passed through as this task started wait duration environment variable.
Cool. Okay, thanks.
All right, if there are no further questions, I will hand over to the next one, which is Keptn.
Oh, okay. Good that I'm already sharing. So I have only one issue prepared to show. It's about, yeah, more or less housekeeping stuff and knowing our dependencies together with their licenses. In the beginning, I've just yeah, took a look more or less manually and actually wrote a script about finding out what dependencies we are using in Keptn core as well as in Bridge, and try to figure out what are the licenses for those dependencies. In the end, I've created now, I've wrapped this script actually into a GitHub workflow we can now use. I can quickly show you how this works. For example, for our main repository, Keptn, we now have here a new workflow to execute, which is called dependencies and licenses. Yeah, I've already executed that 9 hours ago, and we can take a look what this does. Actually, yeah, let's take a look at the logs here. It's actually analyzing each and every module, Go module of our repository. You can see it here: API, proof of service, CLI, etc. And then it's, yeah, analyzing the dependencies and tries to figure out what licenses come with those dependencies. And those will then listed here. Apart from that, after this is done, it also analyzes the Node.js and the Angular module, which is our bridge, and also analyzes the dependencies there together with the licenses. What comes out of this action is an artifact you can see here, which is called Dependencies and Licenses. If we just open that one, we can see there are two files in there, dependencies, licenses, go. If I open that one, I just see a comma separated value formatted list here, which is just listing all of our dependencies. There are 63 or something like that of them, and that's the dependency, and then the license which comes with that dependency, and the same for the bridge code. How it's done. Basically, I was looking for already available tools that will tell me what are dependencies together with the licenses for a Go binary, for example. I've evaluated different tools available out there. There are a couple of them. In the end, I've used how is it called? Go license detector, which is a tool created by Elastic, I think. This one performed quite well and gave me just the dependencies and licenses for a Go module. What's nice here is that you can provide a template. For example, I've used or created this template here, where you can then just define how the output of this tool will look like. As you saw, it's a CSV file in my case. So that's the format, actually, dependency name, comma, version, comma, license type. But it's quite nice. And for the node dependencies, I've just took the, where can we see it? Analyzing. Is it part of this?
I think Node was in the second PR, right?
I think there was another PR, but the tool was called license report. It was much more easier than collecting the dependencies for a Go module, because we only have one node module, which is the bridge, and I just executed it, and it spits out basically the already finished comma separated list of dependencies together with the licenses and versions, and that's it. What's good here is that our core code is actually dependent on Go utils and Kubernetes utils, so I'm not only analyzing the modules in this core repository, but also actually checking out the source code of Go utils and doing the same logic there, executing the Go license detector on that code base, as well as the Kubernetes utils code base, and in the end, merging them into one file, removing duplicates, and that's then the outcome of this workflow. So that's only for our Keptn repository, so the core repository. Maybe we will also need something similar for a couple of contrib repositories. Then I think it's best just to reuse the work which was done here in the core repository, and do the same in the other repositories where we might need such an overview. That's it for me. Are there any questions? Okay, then Elizabeth.
Okay, thank you. Just a second. Okay, so I want to present 3 features I implemented in this sprint. The first one is the collapsing of the evaluation heat map. So the idea was that, that when someone has configured more than 10 SLOs, that the heat map can get very very big. And to prevent this, we want to show a button here to collapse and to expand it so that the view is a bit more cleaned up. So it works like this. What I have to admit is that I somehow I have to rework the heat map part of this feature because Klaus luckily found the bug now directly after the pull request. So with the data retriever, there's some problems, but I'm on it to fix it. So this will be finished, I think, yeah, tomorrow. Then another task was to improve the sequence selection user experience a bit, because until now you cannot see, you don't really see what sequence you actually you currently have selected. So I added an hover effect, and also the bar is now a bit better, so you have an overview, a better overview what you are have selected at the moment. And the last thing is just a small text change for the quality gates only use case. So I haven't set up an environment for this, so I will just show the screenshots. So if you have a quality gates only use case, there was I think the onboard service message shown, which is not correct. So in this case now, it's shown that you the instructions are shown how to create a service in different screens, like the project dashboard, the environment view on different places, and also on the service view. So now for quality gates only, it's not a correct message. So yeah, I think that's all. Are there any questions? Okay, then I will hand back to, is there someone left actually? No.
I think we're through.
Okay, Klaus, are there any points to present from your side?
Not really.
Okay.
All
Okay,
right.
then we are through.
Yeah, so thank you all for your presentations, and I think we can today close this call a little bit earlier. And yeah, thank you all, and see you next time. See you.
Thank you. Bye.